Welcome to the Bentley Systems training course to learn how to design pile-supported mat foundations in Staad Foundation Advanced. Over the next series of videos, we will show you the complete workflow for designing pile-supported mat foundations. This will begin with the process of modeling your mat foundations, grade beams, and piles. We will show you how to create surface loads directly on the mat foundation. We will generate the finite element mesh and specify the analysis properties, and then we will go through the analysis and design process, which will include designing the mat foundation and the grade beams. In this video, we will be focusing on the analysis process for pile-supported mat foundations in Staad Foundation Advanced. This will include the process for generating the finite element mesh, specifying the analysis properties, and then finally performing the analysis. To generate our finite element mesh, we're going to go over to our main navigator on the left-hand side of our screen, go to the mat foundation job, and expand this mesh generation group. Now our meshing region has already been created, which is this overall perimeter you see on your screen. Now we need to define this area and generate the mesh, and to do that we'll go to the meshing setup group. The first thing we're going to do is define the region. So I'm going to go in my main geometry screen and I'm going to select my outermost region, and it should turn red when it's selected. I need to define this as the boundary for my mat foundation. I'm going to go ahead and name it, and I will just call it mat boundary. I'm going to define it as a boundary, and then I'm going to go ahead and click on the Add button. Now for this model, we just have one perimeter mat boundary, but Staad Foundation Advanced does allow you to model holes within your mat foundation and also control regions, which would be an area where maybe some of the analysis properties would differ from the area around it. And to do that, we would just use these other options over here. Now after we've defined all of our areas or our regions, we're now ready to perform our finite element mesh generation. I'm going to highlight my mat boundary over in my meshing setup window, and then I'm going to enter my meshing parameters. I'm going to do a target maximum mesh size for this particular model of 36 inches. I'm going to optimize based on the area, and then I'm going to generate the mesh. In the meshing options dialog, I'm going to select one of the three meshing options. I could do quadrilateral meshing, which would be 4 noded finite elements that would create, triangular meshing, which would be 3 noded, or a mixed quad and triangular, and I'm going to go ahead and select that one. When this option is selected, Staad Foundation Advanced will try to generate as many quadrilateral elements as possible, but it may fit in a few triangular elements where that shape might be more appropriate. I'm going to create a node at column support position, and then I'm going to typically leave my optimization level and my internal node spacing factor set at their defaults. If after you generate your mesh you want to refine your meshing a little bit more, you could alter these numbers, which would control the density of your mesh. After we enter all of our meshing options, I'm going to go ahead and click OK. I'm going to click yes, and now my meshing area has been created. Next, we're going to specify all of our analysis properties. So I'm going to expand the analysis properties group, and I'm going to select slab thickness first. Now for this particular model, we are going to model it as an 18-inch thick slab. I'm going to change my units to inches, and I'm going to enter the analysis thickness as 18 inches and also the same thing for the design thickness. Now Staad Foundation Advanced does allow you to specify different thicknesses for both analysis and design, and the analysis thickness will be used in the finite element analysis of the mat foundation, while the design thickness will be used to design the mat foundation. We're going to specify both these values as 18 inches. Next, we're going to select the soil property area. Now for our particular mat foundation, we are going to model this as a pile-supported mat foundation. So I'm going to find this Use Soil Spring checkbox, and I'm going to leave this unselected. This is what will tell the program to use the piles instead of a soil spring. I can still enter a density of soil, and I'm going to enter 110 pounds per cubic foot and a soil height of 2.5 feet. Lastly, I'm going to enter the pile spring values. So go ahead and select pile spring, and I'm going to enter this information here. I'm going to enter my KX, my KY, and KZ. And actually, I had all these values set up as defaults on my computer, so they're already entered for me. If not, you can manually enter them here. And if you want to set them up as default properties, you can use this area in your main navigator. Now, before we go ahead and perform the full analysis of this mat foundation, whenever your analysis properties change, such as your slab thickness or any geometry or any other information, it's always good practice to go back and regenerate your mesh before analyzing your mat foundation. So I'm going to go here back to my meshing setup area. I'm going to select my mat boundary, and all I have to do is click the Generate Mesh button again. Specify the same parameters I had before, and I'm going to go ahead and click OK. We are now ready to perform the analysis, so I'm going to expand this Mat Analysis Design Options area, and I'm going to click on the Analyze button, and I'm going to confirm this process with Yes. Now, depending upon the complexity of your model and your processing speed, your analysis time may vary. After my analysis is complete, I can see a variety of analysis results available either on screen through graphical format or through the tables at the bottom of the output pane. To view this information on screen, I'm going to go over to my main navigator and select the Output View Options command. Here right now on my screen, I'm showing my nodal displacements, and I can actually see the deflected shape of my mat foundation right on screen. I can also show my plate stresses and my beam stresses. So to show my plate stresses, I'm going to go ahead and select my Show Plate Stresses radio button, and I'm going to select from any of one of the stress types are available. And here I'll just go ahead and select Max Absolute. I'm going to see my slab is now color coded, and I have a legend at the left hand side of the screen indicating the values for each shaded region. All of this information that we're going to see available on screen is reported according to the currently selected load case. So here, if I wanted to select a different load case or combination, I would select it up here, and then I'm going to see my legend change and even my color coding. For that similar information for my beams, I'm going to go back to my stress contour area. I'm going to say Show Beam Stresses, and I'm going to select from a stress type. I can show some bending, axial, or even some combined stresses. And again, this is according to the currently selected load case or combination. To see some of your analysis results available in tabular format, I can flip through the different tabs at the bottom of the screen, such as I have a displacement tab or a displacement summary. Now, any of the summary tabs will give you kind of an envelope solution for the worst case scenario, and this also might be a good place to look for to see where your critical load cases or load combinations are.